Leaving Cert Higher Level Maths 2024. This is the solution video to question 8 from paper 2. So question 8, here it is. Tommy makes ornaments from metal and glass. He makes an open metal cylinder with a height of 15 centimeter and a radius of 5 centimeters. The net of the cylinder is a rectangle. Find the dimensions of this rectangle. So obviously if it's 15 high, we're going to have 15 here. So dimensions is 15, and then the length here is going to be the same as the circumference of the circle of radius 5. So we just say 2 pi, or that's equal to 2 pi times 5, which is equal to 31.4. So 31.4, and it's in centimeters, so stick centimeters there for both of them, and that's worth 5 marks. Tommy makes another cylinder with a height of 22 centimeters and a diameter of 12 centimeters. The cylinder fits exactly into a glass sphere. The top and the bottom edges of the cylinder touch the sphere. Find the volume of the sphere in cubic centimeters correct to 1 decimal place, and use the theorem of Pythagoras in your solution. So what you can do here is draw a right angle triangle going from here up to, we have a diameter there of 12, and this bit here touches the circle. So the height of the cylinder is 22, so that means half of it is 11. This is 12, so that means that half of that is 6. So then we can find the radius of the sphere here. We call that x. So, or we can, maybe we'll call it or for radius. So or squared is equal to 6 squared plus 11 squared. So or is equal to the square root of that, or is equal to the square root of 157. So that's the radius of the cylinder, is square root of 157. Sorry, not 155, 157. So then the volume of the sphere, volume is equal to 4 over 3 pi or cubed. So just stick in or here, 157, and cube it. And you can pop that straight into your calculator to get 8,240.2 centimeters cubed. That's worth 5 marks. On to part C. So another ornament is made up of 2 cones inscribed in a sphere. The top cone is upright, the bottom cone is inverted. The cones have the same base, so they're joined here in the same base. A vertical cross section of the ornament is shown here. It's taken through the center, shows 2 cones as triangles, ABC and ABD, with a common side AB. ABC is the top of the cone. The points A, B, C, and D all lie on the circle, which represents the cross section of the sphere. The lines A, B, and C, D intersect at the point E. The diagram is symmetrical about the line DC. State why CBD is equal to 90. So why is this CBD equal to 90? Well, that's simply an angle standing on the circumference on the diameter. So angle at circumference standing on diameter. That is always going to be 90. Hence or otherwise, prove that the triangles BCE and DBE are similar. Give a reason for each statement you make where appropriate. And there's more space on the next page, but you can actually fit it into this little block here. So we have, first of all, the angle, the size of the angle, CEB is equal to the size of the angle DEB, and they are both 90. Then we have the angle ECB is equal to 90 minus the angle EDB. We also have the angle DEB is equal to 90 minus the angle EDB as well. And you can follow that along in the diagram. So that means that these two angles are equal. So angle ECB is equal to angle DEB. So we have these two angles are equal. We have the two angles that are both 90. So that means the remaining angles are equal. So that means, so angle CBE is equal to angle EDB. And your reason for this is angles add to 180. Angles add to 180 in a triangle. And that's all you need for that proof there. If you want to, there is room on the next page to spread it out a bit. This part here, part C, is worth 20 marks altogether. On to this next part there, we have the top cone has a radius of r and a height of h. That is, the length EB is equal to r and the length EC is equal to h. The sphere is represented by S and has a radius of 10 centimeters. So just to show you on the diagram here, we're looking at this triangle here and this triangle here. So what I can say is r over 20 minus h, that's r over this length. So this length over this length, r over 20 minus h is equal to h over or h over or h over or. So using the similar triangles there. And then we can rearrange to get this here. So cross multiply, you'll get r squared is equal to h times 20 minus h. And then just multiply out that right hand side. R squared is equal to 20h minus h squared, which is what they were looking for. So that's 10 marks for that section there. On to part IV, part 4. Hence, write the volume of the top cone in terms of h and pi, and find the value of h that gives the maximum volume for the top of the cone. So there's a bit of differentiation coming into this as well. So the volume of the cone is equal to 1/3 pi or squared h. So that's equal to 1/3 times pi times 20h minus h squared times h. So that's equal to 1/3 pi times 20h squared minus h cubed. Now if we want to find the max, we'll go ahead and differentiate. So dv dh is equal to, now technically it's a product rule, but when you differentiate this, you'll get 0. So half of the product is going to be gone. So you can just work on the first half of the product, which is 1/3 pi times the derivative in here. So times 40h minus 3h squared. So let that equal to 0 and we can solve for h. Divide across by 1/3 pi and it'll just give you 1 here and 0 here. So that's 40h minus 3h squared is equal to 0. Factor out h times 40 minus 3h is equal to 0. So that means h is equal to 0 and h is equal to 40 over 3. So we obviously can't have a height of 0, so we have a maximum height of 40 over 3. And it's in centimeters. And part IV was worth 10 marks. Okay, so if you have any questions, just ask in the comments below, and I'll see you in the next video.